So welcome students to the concept clearance of steering and suspension system. So in last two periods I already dealt with the steering system. So you already know this thing is that so we have got a steering wheel where we give rotary motion where we give rotary motion, and this rotary motion has to be converted into angular displacement of at the wheels. So you are giving motion here, but at the wheel you are giving angular displacement so that you achieve directional stability of your vehicle. The very common principle on which the steering is based is that all the wheels, if you have got this automobile, all the wheels, whenever the vehicle is being turned, should meet at common common center. This is the main principle of the steering system. And steering is to be designed such that you can turn the vehicle at your will. Then you should reduce the wear and tear. Then you should achieve direction stability. You can multiply the effort of the driver, and you want to have a perfect rolling resistance. So the basic system I have already told you regarding the steering. The steering consists, I already told you, the steering wheel, the steering column, the steering gearbox, then the drop arc, which is also called as a Pitman arc, and then you have the tie rod. After the tie rod, we have got, at the end of the tie rod, we have got the steering knuckle, and which is attached to the stub axle. So this system starts with the steering wheel, you should understand. So this thing also clearly mentioned over here. You can see here again the wheel, the steering column, the steering box, then you have got a arm, and then a drop arm, you have got a tie rods, and then at the end of the tie rods you have got a knuckle joints. Okay, so due to these are the all parts of the steering system already dealt with. So basic principles which are coming from the theory of machines. What are the steering mechanism? The very first system is the Davies steering mechanism. So it fulfills the condition. I already condition is that whenever the vehicle is turning, all the wheels should meet at a common arc. Common arc should have arc which is meeting at a common center. So this uh, Davis steering is one of the mechanism which was devised to steer the vehicle, but the most common that is being used is the Ackermann steering mechanism. You have got here the four wheels. These four wheels, we can find out the four wheels over here. You can find out the four wheels over here. These four wheels, you can find out the four wheels, 1 2 3 and 4. I already told that when they are turning, they should turn at these arcs should have common center. So when this condition is fulfilled, we say that we have got a steering mechanism, that is a steering condition for the steering mechanism. And the Ackermann, the mathematical steering equation developed was cot theta I minus cot theta O d by L. And that is the d by L means this distance, the distance between the wheels, and distance between, there is a distance between the rear and the front wheels, and the distance between the rear wheels or the front wheels, that is common. So that should be d by L is the mathematical equation to achieve the Ackermann steering. So you can find out in the Ackermann steering, it is actually a 4-bar mechanism. 4-bar mechanism. It is a 4-bar. This can 1 2 3 and 4 bars are there, and by the help of which you can just get your steering. So this was already dealt. I'm just not going into details for this. So steering gear ratio, already told you, it is 12:1 for the cars. You should remember, this is very important. what is the steering gear ratio for the car? It is 12 is to 1. It is 12 is to 1. When I say the steering gear ratio is um, that is 16 is to 1, that means that when the steering is rotated 16 times by hand, the drop bar will rotate by only one revolution. So drop bar at the end of the steering gearbox, we have the drop bar. The drop bar will go for only one revolution. Thereby, after the drop bar, we have got the tie rods, and the tie rods give you the reciprocating motion, the to and fro motion. We have what I have told you, that you get a rotary motion here, but at the that is a tie rod. If this is a tie rod, this tie rod gives the reciprocal motion, and this reciprocal motion is converted by the knuckle joint. Knuckle. I am again telling you, there is a knuckle joint over there. At the both ends, we have got a knuckle joint, and this knuckle joint at the end of the tie rods give the angular displacement to your wheels. So to achieve the requisite angular displacement, different mechanism have been tried. The very first mechanism here is the rack and pinion arrangement. So in the rack and pinion arrangement, you can see there is a pinion and there is a rack. That is you have got the again I just suggest tell you that we have got a steering wheel. From the steering wheel, it the motion goes to the steering column. From the steering column goes to the steering gearbox. The steering gearbox consists of a pinion and a rack. So as the you are giving rotary motion, the rotary motion is initially given to the pinion. Pinion is meshed with the rack, and rack can move to and fro. At the end of the rack, I am again telling you that at the end of the rack, we have got the various control arms, we have various tie rods, and after the tie rods, we have got the knuckle joint over which the wheels are mounted. So you get angular displacement at the steering knuckle, and give angular displacement to the wheel to give you the specific direction. So you can see over here again very clearly, I have just showing over there. This diagram again clearly shows how the steering is achieved. So you have got a steering wheel, you have got a steering column, you have got this steering shaft, it's a column. Then you have got the gearbox over here. To the gearbox, I already told you this is a gearbox. You have got a gearbox over here, and to the gearbox, this is a gearbox. You have got a pinion and you have got a rack arrangement. You have got rack, you have got a rack. So this rack moves to and fro. So therefore we can give the angular displacement via tie rods and the knuckle joint to the wheels. Our main aim is that though we are rotating the steering wheel, we want the angular displacement of the wheels to achieve directional stability. So different kinds of these movements, that is we want movement, angular displacement. So rotary motion should be transmitted into the reciprocating motion or the to and fro motion, and hence the angular displacement at the wheels. So various arrangement are there. So the very first arrangement is the rack and sector arrangement. Also this is one of the method. Worm and sector, that is called as worm sector. So you are giving movement to the sector, the worm gives you the reciprocating motion which we want. Then there is a recirculating ball type of arrangement, in which we have again one sector gear, which is meshed with the worm gear, and a worm gear gets the reciprocating motion, and the reciprocating motion is given to the tie rods. See, understand the things I am again telling you. So again you have got another method, cam and lever arrangement, in which again you are giving that is a movement to the cam, and then finally from the cam the movement is transferred to the lever in the cam and lever. Then a screw and nut. So you are giving movement to the nut, and when you are giving the movement to the nut, the screw moves to and fro, and you give movement to the tie rods. This is another method. The most basic method that is being used, you should understand, is the rack and pinion. the mechanism that is being used. So we know that if you just have driven the vehicles, the heavy, that is in any the short, that is the low cost vehicles such as the Maruti and 800 and that, so they don't have got a power steering. So the effort which is needed to steer the vehicle, steer the wheels is more in case of the Maruti 800. The reason, because we don't have power steering. The power steering is a mechanism that is being used to assist the movement of the rack and pinion. So the generally the power, and when I say there is a power steering, when I say there is a power steering, so there is a mechanism. There is a mechanism in which uh, there is a pump, there is a control valve, and what happens is that when the steering wheel is at rest, the fluid will exert. So generally there is a hydraulic system, the fluid will exert the same pressure on both sides of the hydraulic ram. But whenever there is an imbalance, means you are moving the steering wheel, so the steering wheel will move the control arm, and where control arm in a such a fashion that more fluid will be given to where the direction where it is needed, and hence what I say that you get power assistance. So power assistance we are getting, so that is called as a power steering. Power steering. So power steering. So you are getting the additional movement. You are getting here the additional movement. So this you can see this component tie rod is being moved, but this tie rod is being given assistant movement by the help of the fluid lines and having a hydraulic piston which also moves alongside the tie rods. So we come to the wheel alignment. So is the wheel alignment necessary? Can you tell me? Anybody can tell me? Are you present over here? Anybody can tell me? Do you know the wheel alignment, or is wheel alignment necessary? Anybody can tell me? Is wheel alignment necessary?
Yes, necessary.
A wheel alignment is necessary. So why it is necessary? So that we can adjust the angles of the wheel so that they are perpendicular to the ground. आपके जो आपका जो व्हील है, इफ यू हैव गॉट दिस इज द योर व्हील, दिस व्हील जो भी व्हील है, so this wheel should be perpendicular to the ground. This should be perpendicular to the ground. It should not be inclined. This you can see, this is the inclined one. You can see I just drawing this. This is the inclined wheel. We don't want such inclined wheels. We want the wheel should be perpendicular. So therefore the wheel alignment has to be done. Wheel alignment is to be done, and the purpose of this adjustment is the maximum tire life, and a vehicle tracks the straight and true when which it is driving on the straight or unlevel road. So how the wheel alignment is done? So for the wheel alignment, when I say there is we want wheel alignment, so wheel alignment depends upon camber. Just remember, when I say you are going for the wheel alignment, you are going for the camber adjustment, you are going for the caster, you are going for the caster arrangement, caster angles, caster arrangement, you are going for toe in and toe out, toe in and toe out. So when I say that I am going for the wheel alignment, I am adjusting these parameters: camber parameter, caster parameter, and a toe in and a toe out parameter. When I say I am adjusting the camber, so this camber is adjusted by eccentric cam, which is located in a control arm shaft. This one thing, when I adjust, I'm saying that I'm going for the caster arrangement, so I'm inserting eccentric bushes or wedges in the suspension system. So when I'm saying that I'm going for toe in and toe out, I am adjusting the screwed portion on the track rods. So these three conditions, by the help of these three methods, I am going for wheel alignment with the sole purpose that my wheel should be vertical. So when a wheel is vertical, there is less and less wear and tear on the wheel, and its life increases. So already told you regarding the caster and that is suspension geometry. This is also called the steering geometry. This is also called as steering geometry. In the steering geometry is included, when I say steering geometry is included, the very first is the camber. So I just go beyond camber. So what is camber? So camber is tilting in or out of the front wheels from the vertical when viewed from the front of the vehicle. From the front of the vehicle when we are viewing. So this is, if I say this is the front part. This is the front part of your vehicle. When you are seeing the vehicle from this front part, you can find the tilt. ये जो आपको tilt दिख रहा है, you are finding this tilt. You are finding this tilt. You are finding this tilt. You can find this tilt. You can find this tilt. So this tilt is with respect to the vertical. This is respect to the vertical. So when we can see the that is the top wheel tilts out, that this top is tilting out, ये direction में, इधर के direction में है, tilting out. So when it is tilting out, when it is tilting, this I say this is a tilting out. When it is tilting out, when it is tilting out, this is said to be positive camber. But when I'm again telling, the the top of the vehicle tilts in, so you can have, again I'm just drawing over here the line, the vertical line. So you can see here the vertical uh, drawing. So this I'm just drawing the line now. This is the inclined line, and this I'm just drawing now the vertical line. So when you can see that the top of the wheel is tilting in, so that is called as the negative camber. So we have got a positive camber and we have got the negative camber. So if if you increase, so very true, if we are increasing the positive camber of the vehicle increases, that means that outside of the tire will wear. ये जो outside part है, so this outside part is going to wear more. If it is a negative camber, the inside part, ये part पे wear होगा. ये पहले इधर होता था तो इधर होगा, जैसे तुम्हारा ये. So here you can see here. Hmm? So what is happening in the camber? So camber angle is generally less than 3 degree. You can just note down these things. The camber angle is less than 3 degree. It is less than 3 degree. It is less than 3 degree, and camber is built on the front wheels for various reasons, so that now you can place the load. So if you are giving the, that is camber over here, camber over here, you are giving the camber I say, and then you are placing the load. You are placing the load over here. Here the load is being placed. So as you are placing the load over here, the vehicle, the tires get uh, straight. They straighten out. I say they straighten out. So we need them. So if it has not been the camber, if you are not giving camber, so there would be negative camber then. So positive camber is desirable to take the loads. I am just telling you, take the loads. We are giving the when we are giving the loads, the positive camber occurs. So to avoid, so this also, since we give the camber. Camber is generally incorporated in the front axle during fabrication, and this results in the net camber of approximately zero when the vehicle is operated on normal design load. So just you remember that all vehicles which are flying on the roads are given the positive camber first of all, and when the design load comes, the wheels rule truly. That means the wheels are vertical to the ground, and hence the wear of the tire is less. So that is the camber. Then is the caster angle. So what is a caster angle? So Kester angle, again telling Kester angle is measured in degrees. This is in degrees, and it is formed by rearward or forward tilt of steering axis from the vertical when viewed from the side of the wheel. So I just go behind the so that I can see the diagrams. So yes, you can see here. So this is here you can see this is the front of the vehicle from here. This is the front of the vehicle. So you can see the rearward tilt of the steering axis with respect to the exact vertical. So I say this is the positive this is the positive caster. This is a positive caster. This is a positive caster. Whereas if I see the steering axis is that is steering axis is having a rearward tilt, is a rearward is a negative caster, and in between you have got the neutral caster also. You get neutral caster also. So this is also I have just shown you. So here this you can see this is the front part of here. So when you can see this one, ये जो दिख रहा है आपको, ये जो tilt दिख रहा है आपको, steering axis का tilt दिख रहा है. You can see the steering axis tilt. So when you are wearing that is viewing from the front, you are viewing from the front. So you can, that is you can see this is a front side, but you are viewed from the side of the vehicle. You can find the angle that is called as caster. So caster is used to make actually is a caster angle is adjustable and has got little effect on the wear, but also it is generally used to maintain directional stability. Number to increase the steering returnability. That means the steering wheel. See, if you are just driven the vehicle, you know that when you are driving the vehicle, so you just turn you rotate the steering wheel, you rotate the story steering wheel जो है हम rotate करते हैं, जो steering wheel है. So this steering wheel, you rotate the steering wheel, but happens that you can find that the steering wheel again comes in the back position. So this is achieved due to the caster. So it also reduces the steering effort. So generally the caster is kept in between 2 to 7 degrees, 2 to 7 degree. सो दिस इज फॉर द कैस्टर. जस्ट आई एम टेलिंग यू, ये कैम्बर हो गया, कैस्टर हो गया. ठीक है. नेक्स्ट इज स्टीयरिंग एक्सिस इंक्लिनेशन. स्टीयरिंग एक्सिस इंक्लिनेशन इज आल्सो कॉल्ड एज केपीआई. इसको हम केपीआई भी बोलते हैं, स्टीयरिंग एक्सिस इंक्लिनेशन और केपीआई. स्टीयरिंग एक्सिस और केपीआई. सो द इट इज एंगल मेजर बिटवीन द वर्टिकल. यू कैन फाइंड हियर द वर्टिकल. ये जो दिख रहा है आपको, ये वर्टिकल है. ये आपको दिख रहा है, ये वर्टिकल है. Assign the vertical. So it is the angle measured in degrees between vertical and line drawn between the center of ball joints when viewed from the front of the vehicle. So this is the ball joints over here. So this angle is called as the steering axis inclination. So line drawn through the ball joints, through the center of ball joints, and the vertical, that becomes the steering axis inclination. So generally, the inward tilt is desirable, and it helps to provide steering stability, reduces steering effort. It tends to keep the front wheels rolling straight ahead. So in steering axis inclination in the present day ranges from 3.5 degree. It ranges from a 3.5 degree, just remember 3.5 degree to 8.5 डिग्री. जो स्टीयरिंग एक्सिस होता है, जस्ट यू कैन रिमेंबर दिस एंगल कितना रहता है, एंगल कितना टिल्ट देते हैं, 3.5 to 8.5 degree. And this has got pronounced effect on steering effort and returnability. I'm again telling that you are, see, if you have got your steering wheel, you are rotating the steering, it should come to its position very fast. So that is the most important effect of the steering axis inclination. So it recovers. So your steering wheel returns to its position due to the steering axis inclination that is being given. So next is the toe in and toe out. So toe is the amount in millimeter or degree in which the front wheel will point inward or outward. If the front wheel are pointing inwards, it become a toe in. I am again telling, front wheel will point inward, so it will be toe in. If it move, it will the point outward, it will be toe out. अगर बाहर निकलते हैं उसके पैर, पैर जैसे व्हील जैसे पैर जैसे अगर हम बोलते हैं तो बाहर निकलते, इफ जस्ट पॉइंट आउटसाइड आई से टो आउट, इफ जस्ट पॉइंट इनसाइड इट इज टो इन. So this is necessary to ensure parallel rolling of the front wheels and side slipping, also excessive wear of the tire. So toe in is also necessary. You can see the toe in over here. ये देखो ये toe in है. They are pointing inwards, toe in. If they are pointing outwards, ये point outwards कर रहे हैं तो toe out हो गए. So again, if that is if the distance A is greater than B, we can say toe in, or when the distance A is that is A is greater than B, I say it is the toe out, toed out. So generally toe in and toe out. So if I just draw the that is a diagram over here, that is about these wheels like this, these wheels like this, and now suppose this is angle, this is distance A, and this is distance B. So now the condition of distance A is greater than B, I say it is toe in. If greater distance A is less than B, it is toe in. If it is greater than B, it is toed out. Just understand. So why we need a toe in and toe out, so that it can provide the easiness for the steering. Then it is due to it which the steering linkages can be given moment, and toe out is provided to that is the inward rolling of the wheels due to the condition of the agricultural land, and side thrust. Generally this toe out, toe in, these are जनरली प्रोवाइड ऑन द ट्रैक्टर्स, ज़्यादा से ज़्यादा ट्रैक्टर्स के ऊपर रहते हैं. ओके. सो द टो इज गिवन, टो इन इज गिवन फॉर द मारुति 800 स्वराज Mazda. So toe is always adjustable for the rear wheel.